Anybody missing this handout? Here. Okay, where is it? You're gonna need the, because we're doing worksheet.
Oh my God, I'm not, how would we be?
Okay, so the direction says find the exact value for each expression. Use radian measures for angles. And it says use principal values for inverses. Okay. So principal values, as a reminder, we know we're going to be involving principal values if you ever see uppercase A or uppercase C, right? So these are all going to involve principal values. Okay, so as a reminder, principal values, if it's positive, then it's straightforward. It's going to be the first quadrant. But if you're dealing with a negative ratio, cosine, you're going to be restricted to the second quadrant. For sine and tangent, you're restricted to the fourth quadrant, but fourth quadrant, we have to make adjustment. It's not going to be what we normally associate with fourth quadrant. We have to either adapt them to be negative pi over 6, negative pi over 4, negative pi over 3, or negative pi over 2. Okay, so let's look at number 1, arctangent of -1. You see uppercase A, okay, and we see the need for involving principal values. So in other words, where is tangent of theta equal to -1? Okay. Okay, so where's tangent of -1? This is going to be in the fourth quadrant, so therefore negative pi over 4. Okay, number 2, inverse cosine of -1. In other words, where's cosine of theta equal to -1? Okay. Okay, so we know that cosine is between 0 and pi. So cosine -1 of theta is equal to pi. Okay, unit circle values. Sine of theta equals to -1/2. Okay, we know principal values for sine, fourth quadrant. So negative pi over 6, yeah. So we know that sine is negative in the second and fourth quadrant, right? Sorry, third and fourth quadrant. But principal values says that because of our domain restriction, we're only restricted to between fourth and first quadrant. So fourth quadrant for negative, and then with negatives we have to fourth quadrant we have to make the adjustment. We don't want to use 5 pi over 3, 7 pi over 4, 11 pi over 6. We want to use these values. So normally you would say 11 pi over 6, but to make the adjustment, you will say negative pi over 6. Okay, inverse tangent of √3. Now this is a positive value, so that's easy, just first quadrant. So where is tangent equal to √3? Pi over 3, yeah. Okay, this we got to do one piece at a time. We'll do the inverse tangent equals negative √3 first. So we see that this is in principal values, inverse tangent. We got to be in the fourth quadrant. So where is tangent equal to negative √3? And negative pi over 3. So we'll make that adjustment for the bracket here, negative pi over 3. But the larger problem that we're trying to solve is trying to find the cosine of negative pi over 3. And cosine of negative pi over 3, that's the same thing as cosine of 5 pi over 3, which is just what? Just 1/2. So whenever you see a bracket with inside and outside portion, you got to figure out the inside portion first, make the substitution, and then build out to the larger problem. Our cosine of sine of 2 pi over 3. This is pretty straightforward. We're just looking for a unit circle value. What is sine of 2 pi over 3? 3 over 2. Now we're trying to find the arc cosine of root 3 over 2. In other words, when is cosine of theta equal to root 3 over 2? We're getting a positive ratio, so that's easy, it's just first quadrant. Okay, so cosine is equal to root 3 over 2, and theta is equal to pi over 6. Yeah. Okay, inverse sine of tangent of 7 pi over 4. We work the inside bracket first. What's tangent of 7 pi over 4? -1, good. Fourth quadrant, tangent is -1. Inverse sine of -1. We know we have to involve fourth quadrant here. So where is sine equal to -1? Good, right. Normally you would say 3 pi over 2, but because of principal values, we have to adjust it. Okay, one piece at a time here. Inverse sine of root 3 over 2, and then we'll work into 2 here. Okay, where is sine equal to root 3 over 2? Pi over 3, yep, pi over 3. Now we want to find the cotangent of 2 times pi over 3. Remember that 2 is still hanging out in front. Okay, so I made the replacement inverse sine all the way down to pi over 3, but I still, that's not the angle I'm ultimately looking for. It's really cotangent of 2 pi over 3. Okay, cotangent is x over y. And we know cotangent is same thing as tangent in terms of it says negative in the second quadrant. So cotangent 2 pi over 3 is, yeah, 2 pi over 3 here, -1 over root 3. Or you can say negative root 3 over 3. Yeah, the 2 got built multiplied into that pi over 3 to be 2 pi over 3. All right, so those are our unit circle values. But from 9 through 12, we're going to have to build out using triangles. Okay, build out using triangles. Inside first, cosine of theta is equal to -5 over 13. Okay. Principal values here. So which quadrant do we want to be in? That's uppercase A here. Oh, sorry, yeah, you're right. Second quadrant, right? Second quadrant. Cosine is negative for principal values. Okay. Which value takes the negative? Good. The hypotenuse is always positive. Okay. Pythagorean theorem: a squared plus b squared equals c squared. Or 69 minus 25 is 144. 144 is 12. Now that we have the triangle, it becomes easier. We want to find the cotangent of theta. Cotangent is what? adjacent over opposite, yeah. Any questions so far? Yes.
It's like, why couldn't it be the third quadrant?
Because we're talking about principal values, so principal values, cotangent, sorry, cosine is gonna have to be in either the first or second quadrant. First quadrant for positives, second quadrant for negatives. Because of that uppercase A there. Okay, now anytime you're dealing with variables, you're always gonna build your triangle where? Which quadrant? Yeah, just quadrant 1. Okay, so if you see variables and you're building triangles, just always put in quadrant 1. All right, so first step. Our tangent of 2x, same thing as saying tangent of theta is equal to 2x over what? Over 1. Yeah. Where's the 2x go? Where's the 1 go? Opposite. Okay. A squared plus b squared equals c squared. Okay. Careful how you reduce this. We cannot reduce this root 1 plus 4x squared, even though these are both perfect squares. That plus sign prevents us from doing any cleanup, so it's left us that mess of square root of 1 plus 4x squared. Okay. So what's cosine of theta? Yeah, adjacent over hypotenuse. Yeah. You don't have to rationalize the denominator if you don't want to. It's fine. Okay, work from the inside out. Opposite over hypotenuse. Pythagorean theorem, a squared plus b squared equals c squared. Okay, what's tangent of theta? Good. 5 over the x-axis, right? Yeah, so 5 over the square root. Okay, opposite over adjacent. Okay, Pythagorean theorem. Cosecant, what's cosecant of theta? Hypotenuse over opposite, yeah. Flip sign around. Okay, back page. Okay, use the calculator to find two values of theta, where theta is between 0 and 360. So we're going to start off with degree mode. Okay. Make sure you're in degree mode first. Okay, so arc sine of 0.6191. Enter that in the calculator, solve for theta. Okay, what'd you get for theta? Begin. Theta equals degree, degree mode. Yeah, degree mode. 38, okay, 30 degrees. Okay, that's also the reference angle. Okay, and let's make sure we are targeting the correct quadrant here. Which quadrant are we after here? First and second. Okay, so we want 38 is already one of our answers, but we want to find something that's related to 38, and we have to use our reference angle knowledge to find that. Okay, so how do I find my second quadrant measure? Yes, subtract from 180.
You always round to just like a whole number.
Yeah, round to the nearest whole number. It's, yeah, up here it says round to the nearest degree.
Oh.
Okay, so 180 minus 38 is 42. Here's our two answers, 142 degrees and 38 degrees. Okay, inverse cosine of a negative, these are a bit more challenging, so it's going to feel a little different, but we're just going to go through the same steps. Okay, let's find theta first. What you get for theta? 157. Now, this is not a reference angle, but we're still going to be able to work our way to find our answer. Okay, which quadrant are we targeting?
Second.
Second and third. Okay. Which quadrant is 157 in? Second. So it's one of our answers already, but we're going to have to do a little work to figure out what that third quadrant is going to be. So what would your next step be? Let's find that reference angle, right? If you can find that reference angle, then you can use that to build your third quadrant measure that you're trying to look for. So 180 minus 157, we get 3. And if I know 23 is my reference angle, I can use that to help me find my third quadrant measure, 180 plus 23, which is what? 3. Okay, so inverse cosine negative feels a little different. You're not going to be given the reference angle. You kind of have to work backwards a bit to find that reference angle. Okay, inverse tangent of negative 0.3249. Okay, theta equals negative 18. So here I would ignore the negative. Just focus on the fact that it's 18 degrees and that is your reference angle. Okay, which quadrant are we in? Second and okay. So we'll use that 18 to help us find the two measures we're looking for. Okay, how do I find my second quadrant measure? 180 minus 18, yep. What did we get? How do I get my fourth quadrant measure? Subtract from 360, 360 minus 18. Any questions? Okay, 16 through 18, same idea. We just have to make an adjustment, radians. So instead of dealing with something that's more recognizable now, it feels more obscure. But same idea. It's just instead of these nice angle measures, now we're dealing with these decimals. Okay. All right, so first thing, let's make sure that we're calculator is in what? Radian mode. Okay, so go to your calculator, make sure you're switching to radian mode, otherwise you're not gonna get what we want to do. Okay, enter in the calculator, arc sine. Okay, what's good for theta? Yeah, up to 0.609. Okay. All right. Which quadrant are we going to be in? First and second. Now 0.609 is nice and safe. It is a reference angle because it's less than 1.57, it's less than pi over 2. So we know that's one of our answers. But how do I find my second quadrant measure? Yeah, subtract from pi, right? Now we're dealing with radians, no longer 180, but this idea is still the same, except it's pi minus 0.609. We're going to save the bottom for 19 and 20, so I don't think we're taking that much space anyways, but just let you know, I'm going to do 2 more problems after we get done with these 3. Okay, the challenging problem here is this inverse cosine with a negative involvement here. Okay, theta equals. Okay, what's theta equal to? Okay, 1.77. Okay. Negative cosine, which quadrant do we want to be in? Second and third. Okay, is 1.771, is that a reference angle? It's not. It's already in which quadrant? Or in the second quadrant. Okay, so it's already one of our answers. So same idea as number 14, we're going to have to find the reference angle and from there build out to the third quadrant. Okay, subtract from pi, get that decimal value. Let me know what you get. I would use pi, use that pi notation just to get that accuracy if you can. So if you have that, so pi. I got 1.37. Is that what you guys got? Okay. Now we can find that third quadrant by doing what? Adding pi. Good. Pi plus 1.37. Okay, theta equals. negative something, right? Okay, ignore the negative, just focus on the positive. Is 0.3233 a reference angle for us? Yes, right, it's less than 1.57, so just focus on that 0.3233. Which quadrant do we want to be in? Okay, how do I get to my fourth quadrant value? Okay, subtract from 2 pi. To get to my second quadrant value, subtract from pi.
We subtract, like, did the decimal instead of putting it to.
It's just less accurate. I mean, if you have your calculator, just use the pi button. Yeah. Okay, let me just do two more practice problems from the previous page topics. So if you guys could put down 19 and 20 below. Okay, we got to build out our triangle in the correct quadrant here because there's no variables here. Start off inverse tangent. Okay. Principal values, where do we want to put our triangle? Tangent is negative in which quadrant? Fourth. Yeah. Typically we say second and fourth, but because of that uppercase T, we're going to force ourselves into that fourth quadrant here. Opposite over adjacent, Pythagorean theorem. Okay, so now a little bit easier, just find cosine of theta. Cosine of theta is yeah, you don't have to rationalize the denominator if you don't want to. I'll accept either way.
So is there like a calculator's portion?
No, just gonna give you a calculator for just 5 questions tomorrow. Okay, cosine theta equals negative 12 over 13. Uppercase C. Okay, principal values. Where do we want to put our triangle? Good. Cosine is second quadrant for principal values. Which one takes the negative? Well, Pythagorean theorem. Tangent of theta equals 5 over negative 12. Okay. Okay, I'll give you guys a quiz review worksheet 2. I will go over this tomorrow during a morning review. 7:30 in the morning if you want to join through Teams, or if you want to be in the classroom. But if you feel good about this, it should be a breeze tomorrow. Okay, it's just 5 questions. Class is like 40 minutes, so that's plenty of time to do these. To do 5 questions.
Pretty much are each day. Each.
It'll be like 1 or 2 from each.
Consider it be like inverse cosine.
Yeah, make sure you know that. Okay. Oh. I'll give you unit circle, blank unit circle, but you have your calculator, so it'll be a lot faster to you can get anything you want from the calculator as well. But yeah, I'll give you a blank unit circle. You don't use it. All right, go get your phones.
Figure.